I'm working here at Chalmers, and I've been working quite a lot with circular economy and the built environment. And this is what I want to present to you today, the work we've been doing in the Circularity project. So I will start sharing my slides so we can start there. Wait. I need to share my screen first. Yes. Now, I guess everyone can see my screen now.
Yes.
So yeah. So what I would like to present to you today is this concept that we've been working on digital twin for circularity within the context of the Digital Twin City Center, and also other projects we have been having ongoing. And it has been quite a lot of focus on the reuse and the recycling of materials in existing stock. But before we go there, and of course, this is a work that is led by Chalmers, but it has the contribution of a lot of other partners, both from companies and cities in Sweden, but also abroad, because there's also have an European project connected to it. And I would like to really start first by kind of declaring a bit what is our vision for circularity. So it's this idea that we should have a digital twin of a city where we have a digital material passport for each building and infrastructure. So how do we get there is actually what we've been working on, and we're trying to have a very centered systems perspective approach, so we can really try to go from a theoretical perspective where we look into as much information as we can, and then focus on some use cases, but then come back to this idea of trying to generalize what this vision should look like. So that's what I will try to go through today. So for us to go through that, what we needed first to do was to really try to understand what are the stakeholders involved in this process, what are the interests, and what are the data needs that we should gather in order to fulfill the stakeholders' needs for them to support the reuse and the recycling of materials in this existing stock in the built environment in cities. So that was kind of our first approach. What we did there, we needed to map key variables associated with that and then combining them. And we came up with this concept that we needed to have three main types of variables that are important. One is the phases of the building projects, which include also the end of life. So we should know what this is about. Then we should also know what stakeholders are involved in which of these phases, and then later on connected to what types of information they require to really support reuse and recycling in a more practical way. So what we did there then was to really start first by mapping out the project process. Again, nothing too special, but it was important for us to map this out. We combined it also with the way we need to handle materials. Again, because we're talking about material passports and recycling and reuse, it's quite important to do this. And then, of course, we also map out the different types of flows and where different types of materials will end up if we reuse them or recycle them, or even if we send it to landfill. And again, this is really to give an overview of all of this process, because then afterwards we look into what kinds of stakeholders are involved in all of this process for recycling and reuse. Again, to give an overview of this multiplicity of stakeholders that can be involved. And once we have that, we combined it with the phases in the project and also the handling of the materials to really try to understand where each of them is positioned and even where each of them has the highest power or in terms of the decision-making process. So we did, again, this very overarching work to really map out all of these connections and combinations between each of them. And once we have that, then what we started then looking into, okay, so we know the stakeholders, we know the phases, what requirements do they have? In general, again, we have 6 types of requirements that are needed for reuse and recycle to really go forward. We're talking about technical requirements, knowledge, market, and laws, and so on. So I'm not going into many details, but again, to give you an overview that we mapped these things out. And once we have this information, then what we did next was to really try to understand for each of these requirements, what kind of sub-requirements were needed, and then trying also to map out what type of methods and state-of-the-art approaches exist out there that could provide information to fulfill these requirements. So you see here as an example of the material information and the feasibility retrieval that we try to make and try to understand what information and what methods could be applied to answer different aspects. As you can see there, we have a couple of green dots there or green squares there that shows us that this information that can be satisfied by material cadastre approaches today. Some in yellow that are possible to include in the future, and some of them that right now are not being possible to be fulfilled at all. These are the gray ones in the bottom. So we did all of these things and then combined it then with the previous matrix where we looked into each and every decision maker to really see how, which information they do require at the different stages of the process. And I'm going to give you an example of the architect so you can understand a bit more in detail. So what we did there was we looked into architect in the building design phase, and we looked into all these requirements that I mentioned to you about and try to understand for this specific person in general, these are the information that they need, and these are the information that can be satisfied with approaches that exist today or exist in the near future, or for now, they cannot be approached at all. So this is kind of our overarching goal and our overarching work that we try to map out all of this information. So we have a very generic approach to really understand what can be done. So what we did next, we then dived into use cases and really trying to understand in more detail, in more practical terms, what do this means by developing user stories connected specifically to different stakeholders for different phases of the process. In terms of the use cases we're looking into Gothenburg in Sweden, closely with Framtiden, where their ambition is to identify the supply and the demand of recycled building materials and reusable elements from the existing stock. And also, on top of that, provide some support to the market actors to stimulate this market of reuse and recycling. We also have ongoing processes with Rennes in France, sorry, and Nijmegen in Netherlands. And also we've lately added Vienna as a 4th case study. So we are looking into these cases and trying to define what is it that they want in each of them so we can depart from there. And once we know the use case that I mentioned for you in Gothenburg, what we have is we started drafting user stories for different types of users, different type of stakeholders, and trying to connect with what they want to do and what are their responsibilities and their tasks in more detail, and see if we can then develop a tool for them to be useful for their daily practices. So again, we looked into several of them, and this is specific for Gothenburg. I want to show you the example of the sustainability strategist. So we then drafted this together with in this case with Framtiden to try to really understand what they want out of the tool, and we can look into this text, and some of the things that they were interested was in to understand the spatial distribution of secondary materials and components, knowing what type of components and materials are we talking about, what amount, and when will they be available, and also who is owning the building, so they can better address the issue of how can recycle and reuse. So having this use case and having these user stories, then we can start understanding what we can do to really develop a tool that is useful to be applied in the context, in a practical context, in this case, in Gothenburg. So what we have done so far in the tool development was that first we needed to identify what data sources we were going to use in general. Again, this is very connected with resource cadastre information. So what we used for this tool was to really first know the material intensity coefficients for building types, for different types of buildings, multifamily buildings, single house family buildings, commercial buildings, industrial, educational, and so on and so forth, and then connected with there are different elements that are in these buildings and the components and also the materials. So this is information that we got from a previous work at Chalmers by Paul Gontia, where he described this information for different archetypes of buildings across decades of construction in Sweden. Then having that information for an average building per square meter of ground floor area, for example, then we applied to the information on the spatial information related to Gothenburg using the Lantmäteriet data and also LiDAR data to get information about the number of floors or the height, and then from the height, the number of floors. So that was the bulk of the information we used. Then what we did, we first started preparing the GIS data set. We assigned the types of buildings. We assigned the construction decade for each of these buildings. We assign a type of structure, if it's a brick building, if it's a concrete structure, if it's a wooden structure, and so on, and added the information of the number of floors. After that, we continued to go into the details and added the material information associated with each building by looking into the amount of materials and elements and components that each archetype would have. And this is again an example. So we assign the building elements for each type and each decade. We calculate the material weight of the elements using gross floor area per square meter, for example, volumes and heights and densities and so on and so forth. So we come up with a list of all the materials and the elements and the components that are in each of these buildings. And then we could start mapping out different types of elements that could be included in the different types of buildings. This is just an example for you to know, to see wood beams in kilograms in single family buildings in Gothenburg, for example. So having that data set and having prepared all of it, and then combining it with the user stories that we've created before, then we started developing the tool that is currently in the wireframing stage of development. And this is the welcoming page, just for you to have an idea. What we then have is you can choose what city you would like to focus on. Right now we have Gothenburg, Vienna, and Herne. And once you can choose your city, then you can even go further and select an area where you want to look into more details and see what materials and components and elements of buildings are there in that specific area. So you can choose that one. And then once you choose, then you go into the core of the tool, where we have first on the first screen, we have the building information selection. So basically you start looking into the buildings themselves as a whole, and you can choose different types of buildings. You can choose residential buildings, non-residential buildings, multifamily, single family. So you have several layers there. You can look into the structure of the building or filter the buildings by structure. You can filter buildings by the building size, in this case by gross floor area. You can filter them by ownership type, if that information is available. Also filtering in terms of the construction year, and also demolition year. So when is it likely that these buildings are going to be demolished? And then, of course, you can also see and look into details for each building that is selected with your filters, and get additional information about them. So this is the first screen where you can really dive into the information about the buildings. Then what you can go is you start and you can dive into the material content and the descriptions associated with material content. And then here, again, you have a set of filters that you can apply. You can choose different types of materials by category of material. You can choose also to filter this type of material by the different type of layer in the building that we're talking about. Do you want to look into the skin of the building or the structure and so on? And you also can filter it by different types of elements. So you can also look into how many beams do you have in the structural element of the building and so on. And again, in the middle part, you can explore each and every building in terms of their mass and volume, demolition year, and so on and so forth. And you also get information about the total amount of materials in mass or in volume, if you prefer volume, for the filter that you applied. Then you can even go further and look into additional information that you could have in this building or in these buildings. Again, here it's where the editable part of the software comes more into play, because some of this information was going to be very specific for buildings, and it's going to be only we are going to be only able to collect information bottom up, so one by one, if the owners of the building would like to fill in this information. And again, it's connected to the requirements that we looked into when we looked into the generalized approach, that we identified a lot of different requirements. So what we can see here, for example, that we prepared is that if the owner of the building or someone that has the editable privileges of the software can add information about the accessibility requirements, the acoustic performance, aesthetics, components condition, and so on and so forth. So you can add more information to each and every building, so we can start populating more and more information. Another aspect that can also be edited and is editable is this idea that what is the scenarios for the end of life? Do we want to reuse some percentage or recycle, and so on and so forth? So you can also work around with this. And once we have this, then of course we have the output information out of the model. So what we can then have access to is, for each of these areas that we define, we have information at the building level. We have also aggregated information per year in terms of the material quantities within building layers that we have, but also with elements and associated with the demolition periods that are defined for each of the buildings that are there. You can also look into even more specific details about the content, just on concrete, for example, and just for structural beams or for any other element that you would like to see, and also what is the scenarios for end of life. So this is kind of the tool we've been developing right now, and we're going to develop the software soon, and we're intend to continue improving this with a lot of information. And of course, this brings us back to this idea of what is it that we want with the digital tool, what is it the digital twin, and how we really try to structure the way we think about it and the way we approach this process of digital twins. So I would like to just finish with a presentation on our idea of what a structure of a digital twin should look like if we think about material passports information, and this idea of how to characterize the construction materials that are accumulated in our buildings and infrastructure. So looking into what, where, and how much, but also how detailed can it become with what information and approaches we have today. So from that perspective, we had discussions, and we came up with this idea that if we think about the first level of detail that you can have in a digital twin, we're thinking about building level with using a bottom-up stock modeling such as the one we used, and just calculating the content of materials per square meter of gross floor area and applying to each archetype, and then of course scaling it up to a whole city. Then if we think about moving to a higher dimension of detail, then we look into adding information about the elements, not just about the materials in the building, but also the elements. And then from there, we can even go further and add the information for the components. And of course, all of these first levels of detail they are all based on average material types and quantities. So we're really looking into still a lot of modeling and extrapolation and doing some averaging of these results. Then if we want to really move forward, then we can look into parts of building and try to complement the information we have with artificial intelligence and this kind of approaches, satellite imaging, aerial imaging, web crawling, computer vision, and so on. So we can start trying to add more information into it. And then finally, ideally, we should have a bill of materials for each building. And there are some projects and some technologies right now these days where you can actually start trying to really characterize the building as a whole. And then these two levels of detail, we're really starting to talk about actual material types, quantities, and dimensions that are really, really there. So with this being said, I hope you had a good overview of what we've been doing here. There's a lot of open questions, a lot of things that we can still need to develop. But yeah, just to give you an overview. So thank you so much for your attention. I also would like to give some special thanks to the team at Chalmers. I think it's been quite a lot of work being done. But yeah, so if you have any questions, please just let me know.